Hi guys, so in this video we will be solving this problem, number of valid words. Okay, so let's first try to understand what the problem statement says. So we will be given a list of words and a list of puzzles. Okay, so what we have to do is that we have to calculate number of valid words for each puzzle. You can consider it as a score for each puzzle or something like this. We have to calculate that for each puzzle. So what do I mean by number of valid words and number or score is that what will happen is that one by one let's take each puzzle. Okay, so first above yz, above y z, above yz will one by one consider all the words. So words are what? AA, AS, able, ACTT, actor and actress, not actress, sorry, access. So what will happen is that first above yz will one by one start considering each of the words. There are two conditions which each word needs to be followed. Okay, what are these conditions? Above yz will also maintain a counter also. Okay, so first condition is that for a valid word, first condition is that whatever is the first character in this puzzle, that should be present in the word also. So what we are seeing that first character here is what? A is present over here. Yes, so first condition is satisfied. Okay, now second condition is that all the characters which are present in this particular word should also be present in this particular puzzle also. So here only one character is present, A. The frequency is 4, but we are not concerned about the frequency, means unique characters we are mainly concerned about that. So there is only one character, that is A. So A should be present in the puzzle also. So we can see that A is present in the puzzle also. So second condition is also satisfied. When both of these conditions are satisfied, that means what? This word is a valid word for this particular puzzle, or we can consider that it is valid, so we can increase the count by 1. So we will add 1 to our answer. This particular puzzle has found one of the valid words. Okay, now it will move on to the next puzzle. Next word. Next word is what? ASAS. Again, this word needs to satisfy both of these conditions. So first condition is what? Whatever is the first character in this particular puzzle, that should be present in this particular word. So first character is A. A is present over here also, but we are not concerned about the position. It should be present only, that is what we are concerned about. So A is present, so first character is, means first condition is satisfied. Now second condition is what? All the characters in this particular word should be present in puzzle also. So all the characters are what? A and S. So is A present in the puzzle? Yes. Is S present? S is not present. So second condition is not satisfied. That means what? This particular word is not a valid word for this particular puzzle. So we will not add +1 over here. We will move on to the next word. Okay, now let's move on to the next word. So next word is what? Able. So first condition is what? Whatever is the first character in the puzzle, that should be present in this particular word. So A is present over here, so first condition satisfied. Second condition is what? All the characters in this particular word should be present in the puzzle. So A is present over here. Okay, B is present over here. Okay, L is not present, so second condition is not satisfied. So again nothing will be incremented in the count, because this particular word is also not a valid word for this particular puzzle. We'll move on to the next character, next word, that is ACTT. Again we will check all the conditions. What we are checking is that is the first character of this puzzle is present, is in the word. It is present, so first condition is satisfied. Now second condition, that all the characters in the word should be present in the puzzle. A is present over here. Okay, C is not present, so second condition not satisfied. So this is also not a valid word for this particular puzzle. Okay, now similarly we will move on to the actor and access, and finally we will calculate how many words satisfied for this particular puzzle. For now, let's suppose there are some more examples and we got a count equals to 3. So we stored 3 in front of above yz. Okay, now this work for this particular puzzle is done. Okay, now we'll move on to the second puzzle. Second puzzle is what? Abroad yz. Abroad yz will come over here. Okay, abroad yz, abroad y, z. Now it will again perform the same task. It will again, what it will do, it will one by one start considering all the all the words, and it will find out which are the valid words for this particular word, and it will increase it counts. Okay, so initially count will be 0 for this particular abroad yz puzzle. What it will do, it will start with the first word. What is the first condition? That whatever is the first character in the puzzle, that should be present in the word. So first character is a is present in this particular word. First condition satisfied. Second condition, all the characters of this particular word should be present in the puzzle. There is only one character a is present over here, so second condition also satisfied. So a is a valid word for this particular puzzle. Count will increase by 1. Okay, now move on to the next word, that is ASAS. The ASAS. Okay, so again, first character of the puzzle should be present in the word. So a is present, first condition satisfied. All the characters of the word should be present in the puzzle. A is present, S is not present. So ASAS is not a valid word for this particular puzzle, so nothing will be added. Now able, same, it will go to able. Now again it will check. Okay, so a should be present in the word, so a is present, first character should be present. Okay, now all the characters of the word should be present in the puzzle also. So a is present. Okay, b is present. Okay, l is not present, so second condition again not satisfied, so nothing will be added. Okay, now this particular process will continue on, go on. So abroad it will calculate all the valid words for it, and it will store it over here. Let's suppose the answer came out to be 4. So for abroad we got 4, and similarly then we will replace absolute over here, then absorb, and so on. We will calculate the answer for each of them. Let's suppose here it is 2, 3, 0 and 5. Okay, finally when all the work is done, what we have to do, we have to return an array of this particular score, that is 3, 4, 2, 3, 0 and 5, which represents how many valid words are there for each puzzle. Okay, so this is for the question part. So this was the question. Now let's move on to the solution part, how we are going to approach this particular problem. Okay, so yeah, if we go like whatever question demands us, the first approach that comes to our mind was the one which we discussed right now. We can do this particular approach. Like what we will do, one by one we will travel and we will calculate the score for each of the particular puzzles. But this approach may not help over here. Why? Because let's see why I am saying that. If we look at the constraints, first let's have a look. What it is saying us that number of words are in the range 10 to the power 5, and puzzles are in the range of the order 10 to the power 4. So if we write words are of the range 10 to the power 4, and puzzles in the range 10 to the power 4. Words are in 10 to the power 5. Okay, so if we do this scan, that for each puzzle we will travel all the words, then we are doing a work of around 10 to the power 4 into 10 to the power 5, we are getting 10 to the power 9. Okay, and along with that we will also have to check that whether a particular word is valid. For the second case, what we are doing, that each character should be present in each word puzzle also. So that string scanning will also take some time, but let's ignore that for now. If we ignore also, then we are getting 10 to the power 9, and we can easily get a TLE for this. Like there are chances, we will, high probabilities there we will get a TLE. So we need to improve this solution, and we can improve it also. Let's see how we can improve it. Okay, so let's focus on those aspects now. So one thing is that, let's suppose there is a string something like this. There is a string puzzle ZMA. Okay, there is a puzzle ZMA. Okay, so for this particular puzzle, what we want, that first character is what, Z. So our word should contain what, Z also. Okay, and of the 10 to the power 5 puzzles, for 10 to the power 5 words, let's suppose there are only two words which contain Z. Let's suppose one word is what, ZAB, and another word is ZAC. So for only these two words, what we did, we did a whole scan of this particular array, right? 10 to the power 5. We did a whole scan for this, but only these two characters. Okay, now let's suppose there are some few more many puzzles like this. Okay, for each puzzles there are only some words, like 3 words, 4 words, and each time what we are doing is that we are making a whole scan of this array of 10 to the power 5. So this is a waste over here. We can improve over here. What we can do is that if we maintain some data structure, like what we can do is that we can maintain an unordered map over here. If we maintain an unordered map of character comma some list of strings, something like this, in which we will store the strings, then instead of making a whole scan, what will happen is that Z will go in front of Z and check which all strings contain Z, and it will find out that there are only 3 strings, so it will check only for these 3 strings, and we can save our time in this whole scan. Okay, whole scan of this particular array. Similarly, let's suppose there are some more puzzles like YZA. So Y will do what? Y will go in front of Y and check which all strings contain the character Y, because my first character is what? Y. So whichever string contains a Y, only those strings will be able to pass my first condition, and then I will go to check whether second condition passes or it fails. So it will consider only those strings which contains a character Y. Same for other strings also. Let's suppose above YZ will do what? It will search only for those strings which contains a character A in them. Okay, whichever strings contains a character A are the only potential strings because they are passing the first condition. For those strings only it will check the second condition, whether second condition passes or fails. So we can save a lot of time over here if we maintain this data structure one. We can make one scan of this string once or in order of n time, and then we can save a lot of time. Otherwise what we were doing, each time for each puzzle we are making an order of n scan, and out of these order of scans, most of the scans were not useful to us. So we can improve our time runtime by this particular optimization. For this, what we need to maintain an unordered map of character and string. So let's do one thing. Let's try make this unordered map for now, and then let's try to understand what else can we do to optimize this solution. Okay, so let me full screen it. So we'll be using an unordered map. So unordered map of character, along with that what? An unordered set of string. Why I am using unordered set, I am going to explain you it in a bit. So for string word in words, okay, for string not string, for string character chr in word, what we will do, map one of character dot insert this particular word. Okay, so what we did, let's suppose we consider ASAS. So ASAS contains characters what? A and S. So any puzzle which is starting with A, let's suppose above YZ or ABC, or any other puzzle which is starting with A, what it will see, that ASAS contains A in it, so it can be a potential candidate because it passes the first condition, that whatever is the first character that should be present in the string. So what I have done, in front of A I have stored AS. Okay, in front of S also I have stored AS, because AS if a string is there SAB, suppose, so it will see what is the first character S. So AS is a potential candidate for SAB also because it contains S in it. First condition satisfied, we need to check only the second condition. So whatever characters are present in this particular string, I have stored this particular string in front of those characters. Okay, now why I have used this unordered set over here, because let's suppose in case of AAA, let's suppose what will happen, we will first check the first character. A is present in front of A, I will store A. Again I will check the next character A, again I will store A. So there are multiple occurrences, but we want to store it only once. That's why I have used a set, because set will store it only one time even if you insert it multiple times. Okay, so that's why I have used set. So this part is over. So now let's move on to the next part, like what else can we do. Give me a second. Yeah, so we are done with this much part. So now we have a data structure with us, something like this, which contains a character along with all the list of strings, which contains this character. Same we have for B, similarly we have for C, and so on. Similarly we have for up to Z. Okay, whatever characters are present. So now what I can do is that I will start with one by one above IZ, one by one with each puzzle above IZ, abroad YZ, and what I will do, which is abroad YZ, let's make few more absolute actress and so on. So what I will see, my first character is what, my first character is A. So I will go into this list of A. What are the possible strings in front of A? These are the strings. So I will do a checking for them. Let's suppose this is A, this is AS, this is able, and so on. So what I will do, first condition is already satisfied because my first character is A and these characters contains A in them. I need to check the second condition, that all the characters in this particular string, in this particular word, should be present in my puzzle also, that is above YZ. This check I need to do for all the strings. Okay, so this will take some time, like each time I will have to make a scan. Now let's suppose one more thing, I have done the checking of above YZ and AS. It took some time. Now abroad YZ also starts with what? A only. So for abroad YZ also what I will do? Again I will do the checking of abroad YZ and AS. So I am again, means what I am doing, multiple times I am checking the same string, means I am scanning the same string from left to right. So I am wasting some time over here. Can I improve this time? Yes, we can improve this time, like we can convert it into an order of one check. How we can do that? Let's do one thing. What we can do is that we can represent these strings in bit mask. Okay, we can use the help, we can take bit mask for it. How we are going to do, let's see that. What will happen is that, let's suppose there are total 26 characters. Okay, so what I will do, let's map each character with a position. A with 0, B with 1, C with 2, D with 3, dot up to Z with 25. Okay, so now I want to check above YZ. So not, let's take another example. Let's suppose the string given to me is what, a puzzle given to me is A, B, D. So I will calculate the mask for this particular puzzle. What I am seeing, that this particular string contains A. So in position of 0 I will mark a bit on. This character contains B is at 1, so I will mark 1. Okay, this character contains D is at position 3, so I will mark 1. Okay, rest all characters does not contain, so I will mark 0 for rest of all the characters. Okay, now I want to check whether a particular puzzle and a particular this word are means same or not, that is satisfying second condition or not. So let's suppose there is a word one word is what, one word is bad and one word is BAC. So I want to check whether this puzzle and this word are same, means satisfy second condition or not. Or second condition is what, that second condition says what, that each character of the word should be present in the puzzle also. So if each character of word is present in the puzzle also, then let me calculate the mask of bad and BAC. If I calculate the mask of bad, what I will get, bad is what, B means what, position 1. Okay, A means position 0. Okay, and D means what, D means position 3. Okay, rest all characters 0. Okay, now again let's write the ABD. For ABD mask is what, 1 0 1 1, and mask for BAC will be what, mask for BAC, B is at position 1. Okay, and A is at position 0. Okay, C is at position 2. Okay, rest all characters are 0. So this is the mask for BAC. Okay, now if all the characters of word should be present in the puzzle, then what does it means, whichever position is 1 for the word, that should also be 1 for the puzzle also. If it is not 1, then it means they are not the same. Like we can see over here, whichever position is 1 in the word, these characters are present in the word. So this character should be present 1 in the puzzle also, and we can see that these characters are 1 in the puzzle also. Which characters are 0 in the word, if they are also 1, then there is no problem. But if there is a character 1 in the word and if it is 0 in the puzzle, then it is a wrong, then it means that there are some characters which are missing between the puzzles and word. Okay, like in this example we can see this particular character, that is C. Third position represents C. C is present in the word, but C is present, not present, it is 0 in the puzzle. That means what? Puzzle does not contains all the character of the word. Okay, so this we can see manually. Here we are seeing manually, but how will we get it? What we will do is that we'll perform an AND operation. If we perform an AND operation, what do we get in both of these conditions? We check, we get 1 1 0 0. We check here, we are getting 1 1 0 and 1. Here it was originally 0. Even if we take 1, here we'll get 0 only. We are taking the original case, it was 0. So 0 and 0 is 0, 1 and 1 is 1. Okay, so now if you look at the result, this word and this answer, this is same in this case, and this word and this answer is different in this particular case. Okay, so if this word, mask of this word and mask of this answer, if it is same, then it means what? All the characters which were present in the word were also present in the puzzle. So that means what? Second condition satisfied. And if this mask is different, that means what? All the characters which were present in the word were not present in the puzzle. So that means what? This condition does not satisfy. So this is what we will do. We will perform the AND operation between the mask of the puzzle and mask of the word. If it is same, then it means what? Second condition satisfied, and we will increase our counter. And if it is not same, then it means what? Second condition not satisfied, and we will not increase our counter. Okay, so this is what we are going to optimize over here. So for that, what we need to do is that we need to first, what we need for each, we will traverse in this particular list one by one, but we need the mask of the puzzle and mask of each word also. So first let's do one thing, let's calculate the mask of each puzzle and each string, and let's store it somewhere. So let's make an unordered map of what? String comma integer with two unordered map. One will be what? One will be word mask, and other will be what? Puzzle mask. Puzzle mask will store mask of all puzzle, and word mask will store mask of all words. Okay, and we need this mapping also, like we want A for 0, B for 1. So for this also, let's make an unordered map of what? Character and integer. So let's do this part also first. So we need one more unordered map. Unordered map of what? Character comma integer. Let's make it map 2. So for integer I equals to 0, I is less than 26, plus I, map 2 of this, okay, let's type it, cast into character I plus 97 equals to I. Okay, now make unordered map of string comma integer 2. One will be what? Word mask, and one will be what? Puzzle mask. Okay, let's make 2. Now one by one let's iterate. For string word in words. Okay, for character chr in word, what we will do? Let's make a variable mask, integer mask equals to 0. Okay, mask will be equals to what? Mask or 1 left shift map 2 of this particular character. This is what we are doing. We are one by one setting the bits of a particular position. Like if a character A is present, then A index is what? 0. So we are setting the bit at 0. If character Z is present, so Z index is 25. So we are setting the bit at position 25. So this had been earlier taught to you guys in some other videos, so you can refer that, but I'm assuming that you know how we are setting or unsetting a particular bit. Okay, so after that, this particular work, what we will do, we will store word mask of this particular word equals to what? This mask. Okay, now let's make one more check. If word mask dot find this particular word is not equals to word mask dot end, then what we will do, we will simply continue. Okay, and same task will be done for what, this puzzle mask also. So let's write this here. It will be what, instead of words it will be puzzles, and here it will be a puzzle mask, PUZZLE, puzzle mask. Okay, here it will be puzzle mask, and finally we need to store it in the puzzle mask. Okay, so why, let me explain one thing, why I am checking this line. Like, there can be one word, if it is present multiple times, then why to waste this time? So for saving time over there, I am writing this line. Okay, so after that, so now we have what all things we have. We can erase some things. Yeah, so now we have words, we have converted our words into masks also. So let's erase this part for now, we don't need this now. Now what we can do is that one by one we will take a puzzle, we will iterate on these strings. Okay, and what we have to do is that if puzzle mask of the puzzle mask and whatever is the word mask for this word, will perform an AND operation. If this word mask, if it is equals to word mask, then what we will do, we will increment our counter, otherwise what we will do, simply skip. So let's do this part now, the final part. So what we will do, for string, for string, what is this, puzzle in puzzles. Okay, and now for string word in map 1 of puzzle of 0, we want only those words which contains the first character of the puzzle. So that's why I have written this puzzle 0. We will check if this what, let's write it, if puzzle mask of puzzle and word mask of word, after performing this AND operation, if it is equals to word mask of word, then what we will do, we will increment our counter. So let's make a variable integer, counter equals to 0. Finally we need to return a vector of integers. Let's make an answer, vector of integer, answer of puzzles dot size. Okay, let's make a variable integer k equals to 0. Finally what we will do, puzzles of k plus plus equals to count. Okay, finally what we will do, return answer. Okay, so we are almost done with the coding part. Let's try to run this code now. Okay, so there seems to be some error, we are getting wrong answer. Let's try to figure it out, why are we getting wrong answer. So we have made a map of character and set of string, and we are iterating in the words. Okay, and for character in word, what we are doing, map 1 of character dot insert of word, this part is correct. Then we are making a map 2, and we are assigning to each character. What we are doing, to A we want to assign 0, to B we want to assign 1, to C we want to assign 2. This part is done. Okay, then we have created two strings, two unordered map of word mask and puzzle mask. So in this what we are doing, if our string is ABD, so we are calculating the mask and storing in front of ABD whatever is the mask. Let's suppose the mask is 3, 4, whatever is the mask. So what we will do, for string word in words, if word mask dot find of word is not equal to, then continue it. Okay, otherwise mask is 0. And for character in word, mask equals to mask or 1 left shift map 2 of character, that is right. Then finally we are storing it also in the word mask. Same for puzzles. Okay, puzzle mask dot find of word, then continue mask for character in word, we are finally storing it in the puzzle mask also. So this part is also correct. Okay, map 1 is over here, vector of integer, answer of puzzles dot size, we are iterating in the puzzles. Okay, and finally we have a count variable, We are checking in how map 1 of puzzle of 0, map 1 of puzzle of 0, yeah, this is correct. Whichever, if puzzle mask of puzzle and word mask of word, if the end is equals to word mask of word, then we are incrementing the count, that is correct. Otherwise puzzles of k plus plus equals to, it will be not puzzles, it will be answer of k plus plus equals to count. Okay, it will be answers of k plus plus equals to count, then finally returning the answer. Okay, now let's try to run this code. We have, now we are getting right answer. Let's try to submit it. Let's see whether it is passing or not. So it is passing. So this was for this particular question. I hope you guys would have enjoyed the video.